A chicken is put in the oven. The temperature increases quickly at first. Then the temperature increases, but less rapidly, and then even less rapidly. Your job: draw a graph of the chicken's temperature versus time. Alright, so here's our graph. We put the chicken in over here when it's 40 degrees. Chicken's 40 degrees. We put them in the oven. Then it increases rather rapidly in temperature. It gets to about this point, and then it starts to slow down more. And slow down more in its temperature rise, that is. So this would be one graph. This is one solution to the problem. Oh, and it would also be nice if I told you that this was time, and over here temperature, T-E-M-P. So finally it reaches under 60 degrees here. Here it's 40. You can see it's slowing down. So each year the annual electricity consumption increases. And also the rate of consumption likewise increases. Your job is to plot electricity consumption versus time. Well, the first thing we do is we draw our plot, our graph, and now we have to plot the one against the other. So what will be our consumption? Electric consumption will be here. So we're going to start at some point in electricity consumption when it is here. That'll be our starting point, and the world's consumption of electricity is here. And so it increases. It increases just a little bit there, but the next year it increases. The rate of increase is more, and then the rate of increase is more, and more, and it grows every year. And the rate increases also. This is the rate at which it's going up. So every time the rate increases, it becomes sharper in its turn upwards. And this would be one solution, possible solution to this problem. A drug is injected into the patient, and this is over a period of time, over a time period of 5 minutes. During the 5 minutes, the quantity of drugs increases linearly. After those 5 minutes, the quantity of drugs in the bloodstream decreases exponentially. Graph the drugs in the blood versus time. Okay, so the drugs are injected into the patient here over a period of 5 minutes. And it increases linearly during those first 5 minutes. So this is going to be T over here, and that 5 minutes looks like it's about there. And this is the quantity of drugs in the body. So now he's got a lot of drugs in his body. And the problem says after those 5 minutes, the quantity of drugs in the bloodstream decrease exponentially. So that will look like this. it's going to decrease. That's not decreasing exponentially, but this is. It drops down radically and then gradually lowers off its rate of decrease. So this would be the quantity of drugs in the bloodstream versus time. So in this problem, cancer cells grow slowly at first. Then those cells grow with great rapidity. What we want to do is sketch a graph of the cancer cell growth versus time. First thing we do is we set up our graph, like so. And then the cancer cells do what? Well, they grow slowly at the get-go. Well, how are we going to... Well, let's say there are some cancer cells to begin with, right here, and they grow slowly with time. They grow slowly, but then with time, their rate of growth increases with great rapidity. And it does so with time. And here would be the time. And here would be the number of cancer cells. Cancer cells. Well, that's it for now. So long.